Hey guys! Welcome back to my channel. If you like my videos, please like and subscribe. Today we're going to be learning about parallel and perpendicular lines. Let's get started. So parallel lines are when two different equations have the same slope but different y-intercepts. So an example of this would be if we could say we had this equation right here. So with these two equations, you could be able to tell if it's parallel just by looking at the slope. And so over here you can tell that these equations are in slope-intercept form. So all we have to do is look at the coefficient of x to get the slopes. So over here, the slope for this one is 2 and the slope for this one is also 2. So that tells us, since the slopes are same and the y-intercepts are different, that means that these two are parallel. So as long as the slope is the same, which in this case they're both 2, the y-intercept can be anything else. Just the slope has to be the same. And the y-intercept cannot be the same for both equations because then that's just the same equation. So the second part of parallel equations are on graph, when two lines can be extended into infinity but will never intersect or cross each other. So an example of this can be shown on this graph here. So on this graph you can see that these two lines are going in the exact same direction from both the top and from the bottom. So I could extend both these lines in both directions all the way to infinity, but they would never cross because they have the same slope, so they would never end up crossing. So if you ever see two lines that look like they won't cross, even when you extend it on the graph, that means they're parallel. But just because you don't see them intersecting on a graph doesn't mean that they are parallel. For example, take this little graph right here. On this graph over here, they're not shown to be crossing each other or intersecting each other. But if I go ahead and extend both of these lines, they'll end up crossing each other at some point, even though it's not shown at the graph. So you have to be careful of that when you're finding parallel lines. So now that we've covered parallel lines, let's move on to perpendicular lines. So perpendicular lines are when two equations have opposite reciprocal slopes. So basically, a opposite reciprocal slope is the negative of the flipped slope. And you'll see what I mean when we see the example. So for the example, I have this equation right here, which says y is equal to 2x plus 3. So you have this equation that reads y is equal to 2x plus 3. So the opposite reciprocal is the negative of a flipped slope. So the first thing we're going to want to do is take the negative of the slope, just the negative. So the slope is 2, so the negative of the slope would be negative 2. Next, what you want to do is literally just flip the slope. So negative 2 is basically the same thing as negative 2 over 1, because negative 2 over 1 simplifies to negative 2. So for this, instead of using negative 2, we're going to use negative 2 over 1 as the slope. And we're just going to switch out the numerator with the denominator and the denominator with the numerator. So we're basically just flipping the entire fraction around. And that's going to give us 1 over negative 2, which also simplifies to negative half. So this would be the slope of a line that is perpendicular to the initial equation we wrote over here. So we could write y is equal to negative 1 over 2x plus 3. Now, for the y-intercept for this one can be the same, because since the slopes are different, it's not going to be the same line. But it doesn't have to be 3. You could also write like negative half x plus 4 or 5 or whatever you want. So these two equations would be perpendicular to each other. Another part of perpendicular lines and graphs are when two equations form a 90-degree angle. So let's say we have this graph over here. So if you look over here, both of the lines form a 90-degree angle with each other. So if they form a 90-degree angle with each other, then that means that it is a perpendicular line. Now again, just because they intersect at the graph, it doesn't mean that they are perpendicular. So just be careful of that. Now that we've looked at parallel and perpendicular lines, let's move on to the next page for some practice problems. Let's go to problem number 1. Problem 1 says, determine if the following graphs show parallel or perpendicular lines. So looking at the first one, they give us the equations of the lines. So the first one, both of the equations are in slope-intercept form, and we can see their slopes as both being 2, and their y-intercepts are also both different. And it looks like if we extend the lines from both sides, that they would not intersect. So based on all of this, we can conclude that this graph shows parallel lines. For our next one, they are also both in slope-intercept form, and we can see the slopes as being opposite reciprocals, because one of them is 3x, and the other one is, and the 3 is flipped around like a fraction, leaving us with negative 1/3. So since these are opposite reciprocal slopes, and it shows us that it forms a 90-degree angle right there, we can conclude that these lines are perpendicular. For our last one, it does not give us an equation, but if you look real closely right here, it gives us the 90-degree symbol between the points of intersection of the lines. So we can conclude that this graph is also perpendicular. Now that we've finished problem number 1, let's move on to problem number 2. For problem 2, it says write a parallel or perpendicular equation for the given equation. So the first one wants us to write a perpendicular equation from the equation 5x plus y is equal to 12. So the first thing we're going to want to do is switch this into slope-intercept form. Switching that into slope-intercept form would give us y is equal to negative 5x plus 12. If you guys need a review on how to convert to slope-intercept form or anything like that, you can click on the link on the top right to watch that video. So now that we have this in slope-intercept form, we can see that the slope for this is negative 5. So to convert this into a perpendicular equation, all we have to do is take the negative reciprocal of that slope. So we're going to start off with y is equal to, and then we're going to take the negative reciprocal of the slope. First thing we're going to want to do is switch the sign. So if it's negative, it becomes positive, and if it's positive, it becomes negative. So in this case, it's negative, so our slope here is going to be positive. Next, we have the 5. So for the 5, remember we want to look at it not as 5, but as 5 over 1. So we can literally flip the entire fraction around. So if we have 5 over 1, flipping the entire fraction around would give us 1 over 5. So over here, we're going to write 1 over 5x, and then we can leave the y-intercept as just 12, or we can change it to anything else that we want. I'm just going to leave it at 12. So this over here gives us a perpendicular equation to the given equation. Let's move on to our next one. So again, for this one, we want to convert it into slope-intercept form, giving us y is equal to 9 over 4x. So now this one wants us to find a perpendicular line. So what I'm going to do is take the opposite reciprocal again. So we're going to start off with y is equal to, then we're going to flip the sign, and since this one is positive right now, we're going to write a negative. And then this one gives us a fraction already. So what we want to do is just flip the entire fraction around. So the denominator is now the numerator, and the numerator is now the denominator. So that's going to give us 4 over 9. So our equation is y is equal to 4 over 9. And remember, again, you can just switch the y-intercept to any one you would like, but I'm just going to leave this as is. So this is our answer for this one. Let's move on to the next one. So for this one, we're going to convert this into slope-intercept form as well. Y is equal to 2x plus 5 over 3. So remember, for parallel lines, the slope has to stay the same, but the y-intercept has to be something different. So we can write this out by starting with y is equal to, and then 2x, because the slope needs to stay the same, plus any number you want. So I could write 6, I could write 54, I could write anything I want. I don't even have to write plus. I could write y is equal to 2x minus 6, for example. So I'll stay with that, and this could be one of our answers for a parallel line. So that's it for today, guys. I hope everything was pretty clear. If you like my videos, please like and subscribe. Also, be sure to comment any questions down in the comment section below and to follow me on Facebook and on Instagram. Thanks for watching. See you next time. Bye!